Dear student, today we are discussing the 11th level chapter and the chapter name is set. In this chapter, at first we are discussing some important topic and the law of this chapter, and after that we are discussing some important fact of this chapter. So according our given informations, that is the set concept. At first we are discussing the set concept, then we are discussing the representation of the set. After that we are discussing the few definition about the set, and next some important conclusion of the set and the Venn diagram, and these 5 parts we are discussing today. Next day we are discussing the next part, that is a set operation, the law of set algebra and duality and order pair and the Cartesian product. So we are discussing today only 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10. That is this 5 we are discussing the next day. So we are starting first. What is a set? That is, how can we define the set? The set has a 3 property: well defined, and second is collection, and third is distinct. So in the concept of set we have to think, that is, set must be well defined and the collection and the distinct. If these 3 conditions hold, then we can say this is a set. And we are discussing the presentations of the set. Set is represented by the capital letter. I repeat, the set is represented by the capital letter. Now we are discussing the second part, that is the representation of the set. And set can be represented 2 ways. One is roster form and another is set builder form. Roster form So there are 2 types of representation is there. One is roster form and another is set builder form. In roster form, suppose A is a set and the set A is the set of all vowel in English alphabet, that is A, E, I, O, U. These are the set. And another representation, A is a set, suppose X is a element and X is a all vowel in English alphabet. So we can represent the same set in 2 types. One is roster form. We are giving all elements and we are discussing all elements in roster forms. And in the set builder form, this is the short form of representation of set. This is a short form of representation of set. And X, what is X? X is a all vowel in English alphabet. So in this representation of the set, we can see there are 2 types of representations, roster and set builder. Now we move to the next, that is a few definitions. In few definition, we are discussing finite, infinite, finite set, infinite set. What is a finite set? The cardinality number of the set is countable, then the set are said to be finite set. The example of finite set is, suppose X is a set 1, 2, 3, 4, 5, 6. So this is a finite set. We can count the element. How many number of elements is there? 1, 2, 3, 4, 5, 6. So the cardinality number, that is the n of A, is equal to 6. So we can count it. This types of set is called the finite sets. And when we discussing the infinite set, suppose these are not closed. Here the cardinality number of A is not found by us. We don't know the exactly cardinality number of the given set A. These types of set is called infinite sets. That is, when we are not able to find the cardinality number of the given set, then these sets are called infinite sets. Now we move to the next definition, singleton. Singleton set. Subset, proper subset. Okay. Now we are discussing the singleton set, null set and subset. In singleton set, the cardinality number of the set is only 1. So n of A is equal to 1. This set is called a singleton set when the cardinality number of the set is only 1. Then we can say this set is a singleton set. Now we are discussing the next, that is the null set. What is a null set? Null set or void set or empty set. I repeat, the null set or void set or empty set. In this set, there are no element is there, and representation of the set is this one or phi. So null set has no element in our considerations. And the interesting thing is that null set is a subset of every set, but null set has no elements, and representation of null set is this one or that one according our choice. Now we are discussing the next part, that is a subset. There are two types of subset is there. There are two types of subset is there. One is proper subset and another is improper subset. Suppose a set 1, 2, 3. This is the given set, and suppose the B to C 1, 2, D only once, and many more examples is there. Then now in our discussions, A, B, C, D, A is a set and B, C, D is a proper subset of A. Proper subset of A means that some element is taken and make a set and build a set. If some element of the main set is taken and build a set, then these sets are called the proper subset of the main set. And similarly, phi, we can say, according to our modern concept, phi is defined as a proper subset of A. And now we are discussing the improper. Improper subset A with A, that is A set with the A set is called the improper subset of the given subset A. And now this is the complete of proper subset and improper subset. Now we move to the next. Power set, equal set. Now, the next part we are discussing the equal set, universal set and the power set. I repeat, equal set, universal set and power set. At first we are discussing equal set. Equal set, A and B, two sets are said to be equal if the cardinality number of A and the cardinality number of B is same, and the element of A set and the element of B set is equal but not in order or order, does not any effect. Suppose A 1, 2, 3, 4, 5 and B 5, 1, 3, 2, 4. In the both cases, the element 1, 2, 3, 4, 5 is there, and here also B 1, 2, 3, 4, 5 is there, but not in same order. And the cardinality number of A and cardinality number of B is the same. And one clarification is that if the 1, 2, 3, 4, 5 is there, then no problems. That is in order or not, does not any effect in our discussion of equal set, but the element will be the same. Okay, we are moved to the universal set. Universal set is the biggest set in our discussions. I repeat, universal set is the biggest set in our discussions. Suppose we are discussing the set of students in our West Bengal or in our India, in my country, in our country India. Then the biggest subset in our India is the student of all set together, irrespective of any classes, and this set are called the universal sets. And when we are discussing the cricketer of Indian, all the cricketer together make a universal sets, irrespective of state level and another level is there. And when we discussing in our mathematics, suppose the set of all natural number, then capital N is a universal set and capital N is this way. So when you discuss N is a number, suppose A is a 1, 2, 3, 4 number, then in this discussion for the set A, the universal set is capital N. There is a natural number, set of natural number. So this is the complete of universal set concept. And now we move to the power set. A power set. The power set is a set, the collection of all subset. The power set is a collection of all subset of the given set. Suppose A is a set 1 and 2. Then power set P of A is a 5, 1, 2 and 1, 2. So this is the power set. And how can you find these? 2 to the power n. The cardinality number is 2, that is 2 to the power n, that is the 4. The number of subset of the given set A is 1, 2, 3, 4 according this law. So collection of all subset and represented set is called the power set. Now we are discussing some important conclusion. Some important conclusion is there. In this section, that is some important conclusion is there when we discussing A union B is the B if A is the subset of B A intersection B is equal to A if A is a subset of B. This is the symbol of intersection and this is the symbol of union. We are discussing in Venn diagram what is the unions and what is the intersection in the next. And a set union with the complement of set is universal set. That is, a set union with their complement is always represent the universal set in our discussions. Similarly, A intersection B is an phi if A and B has no common point. So, in some important conclusions, we can use this as a result. Suppose A is a subset of B, then every element of A in B and A is a subset of B and B is a subset of D, then we can say A is a subset of D. I repeat, A is a subset of B and B is a subset of D. Then we can say A is a subset of D. Now this is the complete of some important conclusions. Now we move to the next, that is the last section of the day, that is a Venn diagrams. In Venn diagrams, we are discussing this figure as a universal figure. Universal, that is a universal set in our discussions. And suppose this is the A and this is the B and this one the C. A, B, C is there. And when you are discussing A intersection B, this is the A intersection B. A intersection B. And when you are discussing A intersection C, then this one. Similarly, when you are discussing B intersection C, B intersection C, this one, B and C. B intersection C is there. And similarly, when you are discussing A union B union C, then all. This is a union B union C represented by the Venn diagram. Similarly, if we represent A union B union C complement, then this place, this all the place except this one is called A union B union C complement. And in our discussions, A union B union C union of A union B union C complement is equal to U. That is a U. We can find U by adding this all. Similarly, many more example of Venn diagram is there. And in our discussion, we can use Venn diagram as a medium of solution. That is, Venn diagram is one kind of medium, one kind of language in mathematics to solve the given problems. And Venn diagrams give an idea to solve the problems easily and in a short time. Today 1, 2, 3, 4, 5 is finished. Next day we are discussing this all. Hope the given information and the example will help you to understand this chapter. That is a set chapter, and when you practicing set chapter in the next, this video enrich your knowledge about this chapter and help you to understand this chapter better. Okay.